My name is Ryan Becher. I am a mechanical engineer at Virginia Tech. I had the pleasure this summer of working with John Clayton at the Chemical Biological Center at APG South to develop a training filter for the M48A1 and the M98 filters. Before I delve in, a quick definition. A filter is something that will purify the contaminated air coming into a system and provide clean, breathable air to any of the occupants within said system. The two filters that I'll be diving into today are the M98 and the M48 filters. The M48 is primarily used for mobile platforms, while the M98 is primarily used for fixed installations like underground shelters and ships as well. The big problem that the Army is having right now is warfighters are currently experiencing a shortage of these filters due to some manufacturing issues as well as the way that we use them. So our key tasks for developing a solution to this problem included making a training filter that mimicked the pressure drop across the filter and ensuring that it had the same form and fit as well as training indicators so that you do not accidentally use a training filter for an actual chemical attack. This project was split into 3 phases. Phase 1 was planning. This is where the SolidWorks design and final selection occurred. During this process, our design changed from using a replacement for the carbon to completely printing and manufacturing a replacement for the carbon instead of using, say, beads. Glass beads was a popular concept beforehand. We had no way to measure the pressure drop. So instead, we developed something that we could 3D print to slide into the M48 to mimic the pressure drop across the carbon bed. From there, we tested our SolidWorks designs in the SolidWorks Flow Simulator. From there, we move on to phase 2, where we actually started developing our filter, starting with the acquisition of an M48, drilling the rivets out, taking it apart, disposing of the carbon per SOP, and then reassembling it with the manufactured parts. Phase 3 was prototype adjustment and reports. This is where we tested it and finalized all of our reports. The next steps for this project will include finding a new material other than plastic to make it out of, since it does need to withstand certain temperature and overpressure systems that currently the plastic cannot provide adequate solution for. So predicted Army impact is to decrease waste and assist the soldier in PMCSing their equipment without the need of wasting a functional filter that they could better use in a real chemical environment. A secondary objective of this was to create a training filter that soldiers could use in a simulated environment.